Alright guys, so to begin, continue with continuous data. So we did discrete data before. So in this video, we'll be doing continuous data, right? So if you look at this, they call this a piecewise function. Why? Because the function is defined in between different points differently. So between 0 and 1 is a half, and between 1 and 3 is a quarter, right? And is 0 otherwise. So compared to discrete, you notice in this one, there are values in between, right? So it's technically continuous, right? So it doesn't exist at discrete points anymore. It exists in between two. So it'll be continuous, right? And one thing to remember is that compared to discrete, where you used to add up all the probabilities, in this case, you don't have probabilities for each distinct point. So what you have to do, you have to find the total area on any the piecewise function graph, and that total area must always be 1. Right? So the total area on any the graph for continuous data must always add up to be 1. Right? So let's see if we can sketch this piecewise here to obtain a PDF. Right? So X on a y-axis. So this is f of x. So between 0 and 1 is a half. So 0, 1, we said is a half. So in this case, it's 0 and just before 1 because of the less than. It's not less than or equal to, just less than. Right? So the 1, 1 will not be in this piece here. It will actually be in this one. So the other one is from 1 to 3 and is a quarter. So that will be down here. So from 1 to 3 is a quarter. Right? And this here is your PDF. Right? So you notice it different from discrete. That looks like this. Because at discrete it exists at distinct points. And continuous it exists at all the points in between. Yeah, so have points all here, you have a point, all here, have a point. Then discrete at this point 0, 0, 0, 0. So when you have actual probability at distinct points, so that is the difference in between it. All right. So let's check and see. So if I want to actually check to see if this will be a valid probability distribution, I have to check to see if this total area on the graph adds up to 1. Right? So for this piece A and this piece here B. So for A, length by breadth, the length is 1. Half, 1 by half is a half. And then B, so 1 to 3 is 2. And then 2 by a quarter is a half. And so the total area will be A plus B, which is 1. So since the total area is equal to 1, total area equal to the total probability, which is always equal to 1, this will be good. Right? But takeaway, continuous will normally give it as a piecewise function. When you sketch the piecewise, you obtain the probability density function. All right, total area on the Libby graph will always be 1. All right, so that should take us into the second video.